Hello guys, back here with another video today on abstraction. This is a redo for Mr. Song's 6th period AP computer science class, and in my video I'll be showing some matrix multiplication. I'm going to be using some codes that we quote-unquote abstracted from another coder, and I will show that later in the video. And basically we're just going to be going over some simple matrix equations revolving inverses for 3 of them. So here we have matrix A times the inverse of matrix A, the inverse of matrix A times A times B, the inverse of A times y1, and y1 is just another variable, so matrix y1, and then matrix y2 minus matrix B. And then we're going to make an exception code with a try catch, and basically this is just the link that we abstracted. So let's get into the coding aspect. So I'm going to clear this just so we hide the finishing code. So as you can see, this is my coding. I have my 5 matrices right here: A, B, C, Y1, and Y2. As you can see, I also have this little thing right here, try. So I have a try catch function in this code, but that will come in handy later. And this is the code I abstracted. And the main one I'm going to use is this inverse function. So basically what you do and how to use this inverse function, which this whole project's mainly about, is we have all these equations, and I mean not equations, but methods, functions in a separate class, but in the same package. So I can call to these methods right here, especially this inverse, on a whole nother like sheet of code, which is pretty cool as long as they're in the same package. So right here, to get the multiplication, the product of matrix A and the inverse of matrix A, I typed mat then dot, and I'll just show you what it looks like firsthand. So mat dot multiply. So you see this right here. This is calling. These are all the different methods from the abstracted code, and you just click on press enter. And that's how it's done. And I already have the numbers right there. So yep. I have the for loop following the code right there, and you can see that I did the same thing right here with the inverse. I mat dot inverse, so it's multiplying matrix A times the inverse of matrix A. I have some for loops, and I have a print line space to just make it a little neater. Similar equation right here, except as we know, matrix multiplication is not very logical. The order matters, so the inverse of matrix A times matrix A is different than this code right here. But like the other one, we call the multiply function from this this abstracted code in this different class. We call it the mat class, and once again we also call the inverse function. So it gives us that number. Come down here to see y1 equals matrix A times matrix B. Simple multiplication. We just multiply matrix A by matrix B. Another for loop, spacing. We get down here to y2, which is the inverse of matrix A times y1. So this is going to be a little funky. You're not multiplying the inverse by its normal matrix. You're multiplying the inverse of a matrix by a whole nother matrix. So the numbers are going to be a little bit more funky. But that doesn't change our equation. Just similar to the method, or not method, but equation above here, where it's mat A and mat A, we're just going to do mat A and y1 because we're not multiplying by mat A. Once again, our for loop, spaced lines to even out the code, and here we have y3 equals y2 minus mat B, and we're just going to use this sub mat function that I created on the bottom, which is the one function I did have to make for this video because it was not in this class that we abstracted. But it wasn't difficult. Just simple subtraction, for loops and such, that nothing new to us, and we just subtract y2 by matrix B, for loops once again, and then you see this catch. So from the top, you remember our try function. So we have the try. So if we try all this, if there is a catch exception, then the system will print error, and I will show that what that does. So if it catches any kind of error, it will print out error in the box. So let's run it. Right here we have our x1 equals mat A times the inverse of mat A. That looks pretty correct. We have our 1s and our 0s. And these numbers look a little crazy, but they're really, really, really close to 0. As you can see, it's -2 to the -16th, which comes out really, really close to 0. And these 0.999999s, just basically, that's what you want. You want 1s and 0s in matrix. You want 1 0 0, then 0 1 0, then 0 0 1. And if you're not familiar with matrices, that might sound a little confusing, but this is for a little more advanced users. Same here with our x2 equation. We get our 1s and 0s, just what we wanted. Then this is not where we get our 1s and 0s. We get whole numbers, and they're doubles, as you can see with decimals. Matrix A times matrix B, we get our numbers. Inverse of matrix A times y1, these are not going to give 1s and 0s either. These are just going to be wacky numbers. And then here we had an error on our y3, so in the try catch function, it found the error and printed out error. So that's a little bit of everything. So thanks for watching. Thank you, Mr. Song, for this option of making up the work, and I will see my classmates, maybe if you're in my class, tomorrow. Bye.